Okay, guys, today we are talking about rate of change. So we're kind of moving from equations and inequalities into something called functions, okay? So when we're looking for the rate of change, we can do it in 4 different scenarios. That is verbal, algebraic, graphing, and in tables. So when you have a verbal situation, the rate of change is whatever quantity is changing. So that's if you see something that's like $5 per week, for every one red card, you have 2 black cards, or for every girl you have in the class, there's 3 boys, things like that. That's your rate of change. In algebraic, you will have equations that look like y equals mx plus b, and we'll get into that. You should have seen this before in 7th and 8th grade. But here your rate of change is whatever number is going to be with the x. So that m right there, remember that m is your coefficient. Your coefficient is your rate of change in an equation. In a graph, we're going to do what's called rise over run, which is the vertical distance between 2 points, and you are going to put that in a fraction over the horizontal distance, and I will show you some examples. In a table, you're going to find how much x is changing by each time. So it might be increasing by 1, by 2, by 3. It might be decreasing. And then you're going to find this change in y every time, and you're just going to divide the change in y over the change in x. And we're going to go through some examples that show you how to do that. So here on my first table, I see that x goes from 0 to 1, and then from 1 to 2, and then 2 to 3. So I see that I'm actually adding 1 each time for x. And over on the y side, I see that I'm adding 3 each time. So I'm going to take the change in y and divide it by the change in x. And this triangle right here, that is the Greek letter delta, and all that means is change. Okay, so if you ever see me do a triangle with a y, that is the change in y. And it's so you don't have to write the word change. You can just use this triangle, okay? So I take my change in y over my change in x, which my y changes by positive 3 each time, and my x changes by positive 1. So positive 3 divided by positive 1 is positive 3. So my rate of change is 3. And we're going to do the same thing over here. So we're going to look at how much x is changing by each time. I can see that each time I'm adding 1 to x. On the y side, I see that I'm adding 5 each time. So each time my y goes up by 5 and my x goes up by 1. So those are going to be positive numbers. So I'm going to take the change in y over the change in x, which is 5 over 1, which gives me 5. Down here, this time is a little different. I'm still going to do my change in y over my change in x. And each time, my x is changing by 2 every single time. And each time my y is going up by x. So my x is changing by 2, and my y is changing by 6. So I'm going to take 6 over 2, which gives me 3. So my rate of change here is 3. Okay, and that's because x goes up by 2 every time, and y goes up by 6. And 6 divided by 2 is 3. So same thing over here. I'm going to take my change in y over my change in x. And looking at my x, I can see that I'm adding 5 each time. So you're just kind of looking for patterns when you're doing these tables, okay? And then over on y side, I see that it goes up by 20 every time. So you're trying to figure out what number you're skip counting by, really. Okay, and I'm going to take my change in y, which was 20, and put it over my change in x, which was 5. And that will give me 4. So my rate of change here is 4. Okay, so just remember, you're just trying to find a pattern in the tables. It's nothing that you guys cannot do. So down here, this is more of a applied problem. So I'm trying to figure out who's paying more for their gigabytes of data used on a cell phone plan. So I'm going to start on that top row, and I see that my top row changes by 2 every time. Then on the bottom row, I see that it goes up by 30 every time. So the top row in a table is always your x, and the bottom row is always your y. So remember, I take my change in y over my change in x. So in this case, that's 30 over 2. And I see that Jackie's paying $15 per gig of data used. Now we're going to look at how much Kendall is paying. And I see again that my top row changes by 2 every time. But this time my bottom row is only changing by 20. So I'm going to take my change in y over my change in x, which my change in y every time is 20. So I do 20 over 2. So my rate of change is going to be $10, not 0, $10. And so I see that Kendall is only paying $10 for each gig of data used. So Jackie is paying more. Okay, now we're going to get into something that is maybe a little unfamiliar, and that is finding the rate of change on a graph. So I like to draw triangles, okay, in between my points. So I'm going to start the first leg of my triangle right here at this point, and I'm going to draw it up right to this other point right here, just like that. So I see that that is 4 blocks tall. So that tells me that my rise is 4. And then when I draw the other leg, that is horizontal, and that is called my run. So I see my rise is 4 and my run is 2. And rise is just a way to say the change in y, and run is the change in x. So I'm going to take my change in y, or my rise, and put it over my change in x, or my run. So I'm going to put 4 over 2 to represent my change in y over my change in x. And that is going to tell me that 2 is my rate of change. Oh, shoot. Sorry. I want to go right here. Sorry. Alright, so here it asks us to find the rate of change from verbal situations. So this is something that is most of the time easy to do. And we are going to just kind of go through these together. So number 1 says you spend $130 to buy a lawnmower and you pay $10 per week for gas. Your rate of change is $10 per week for gas. So when you're thinking of rate of change, $10 per week, like anytime per week, per day, per month, anything like that, that is a rate of change. And when you see for every blank you get blank, that is another rate of change. So here, your rate of change is $10 per week for gas. On number 2, you have $45 and you earn $5 per week. $5 per week is your rate of change. And I'm going to skip 3 and 4 for a minute. And we're going to come back to those after I do number 5. So on number 5, it says you lost $8 per day. So losing $8 per day is your rate of change. So rate of change can be negative. On the first one, your rate of change is just a positive 10. And on number 2, your rate of change is a positive 5 because you're earning money. So those are positive rates of change. On number 5, you're losing money. So that is a negative rate of change. So it's going to be negative 8 for your rate of change. For number 3, it says for every mile you run, you can eat 3 donuts. So basically, 3 donuts per mile is your rate of change, which is positive 3. On number 4, for every 10 push-ups, you have to do 25 sit-ups. So I'm going to do that to figure out how many sit-ups I have to do for one push-up. So I'm going to do 25 divided by 10, which gives me 2.5 sit-ups for every push-up. Or a rate of change of 2.5. So here we have that Robert paid $21 per t-shirt, including a $15 screen printing fee. Diane's t-shirts cost, which also include a screen printing fee, are represented in the table. So we know that Robert's fee per t-shirt is $21. And we need to figure out how much we're paying per t-shirt with Diane. So the way we do that is just the same way we've been finding the rate of change. So I see that top row changes by 2 every time. And the bottom row is changing by 10 each time. So the top row is X and the bottom row is Y. And I'm going to take my change in Y over my change in X, which in this case is 10 divided by 2. And we see that for Diane's shirts, you're only paying $5 per shirt. When we do that, we see that our rate of change is $5. So Robert is definitely paying more per t-shirt. So now we're going to practice finding the rate of change in tables some more. So in this first one, I'm going to look for my change in X each time. And I see that I'm skip counting by 5s, or that I'm adding 5 each time. So I know my change in X is 5. And then when I look on the Y side, I see that I'm adding 20 each time. So that change in Y over my change in X is going to be 20 over 5. And they're positive because they were increasing each time. So my rate of change there is going to be a positive 4. On my other table, I see that my X is going up by 1 each time, But my y, instead of going up, it's actually decreasing by 1 every time. So because of that, when I take my change in y over my change in x, I need to make sure that I'm putting my change in y was a negative 1. So then I'm going to take negative 1 divided by 1, which gives me negative 1 as my rate of change. So same thing, I see that I'm going up by 5 each time in the x column here. But then when I look at my y, I see that we're getting smaller. We actually end up in negative numbers. So I'm actually going down by 20 each time. So once again, when I do my change in y over my change in x, I need to make sure that signage is right. So I'm going to take my change in y over my change in x, which is negative 20 over a positive 5, which gives me negative 4 as my rate of change. So looking at this next table, I see that x is going up by 1 every time. And I made a mistake here, guys. I made a mistake that a lot of people would also make. And I didn't realize it until just now. I thought we were subtracting 4 each time over here. But when you look, when I go from negative 16 to negative 12 and then to negative 8 and negative 4, I'm actually adding 4 each time. So I got my signs wrong on here. So when I do my change in y over my change in x on this table, I should have actually had positive 4 over positive 1 and gotten a positive 4 as my rate of change. Okay, so I'm going to skip that because I don't want you guys to see me do that completely wrong and get confused. So now we're here, and I'm going to find the rate of change on these graphs using the rise over the run. So let me back up real quick. So the first thing I'm going to do, and I really want you guys to understand, is I'm going to decide what point I'm going to start working with. And I'm going to choose this one right here. And I always like to do, it doesn't matter if you do the rise or the run first. That's completely up to you. But we're going to look at a couple things. So we see that my run is going to be 1 right here. And I tried to draw this whole line, but on my iPad it just came out crooked and kind of messy. So my run is 1, and my rise is 3. So I have my change in y over my change in x, which is 3 over 1, and that equals 3. But there's something we didn't think about, and that is that my line is going down. It has a negative slope, okay? So it's not going, if it was going up this way, we'd have a positive slope, but we're going down. So since we're going down, this 3 is not actually a rise, but it's a drop. So it's going down 3. So I needed to change my numbers over here to negative 3s so that I could get the right answer. So it's really important when you're solving these to think about the fact that if you're actually going up or down, if your slope is positive or negative. So here, I'm going to start with this point right here. I see that my rise is 2. So we've got a positive slope this time. We're going up and to the right. So we've got a positive slope. If you're going down and to the left, that's negative. Remember, down and left are always negative. Up and right will always be positive. So here, my rise is a positive 2, and my run is a positive 4. So I'm going to do my change in y over my change in x, to get my slope or my rate of change. Okay, so rate of change and slope are the same thing. So I put my change in y, which is 2, over my change in x, which is 4, to get 1/2 as my rate of change. So you can get fractions as your rate of change. That is completely okay if that happens. So now we're going to figure out which function has a greater or the largest rate of change. So here, when I have an equation, the coefficient is always the rate of change. So when you have an equation, there's no math you have to do to figure out the rate of change. It's super easy. Right here, the coefficient is -5, so my rate of change is -5. And now we're going to go ahead and do this table. I see that x is going up by 2 each time. And I see that y is decreasing by 8 each time. So it's going down by 8 each time. So I take my change in y over my change in x, which is -8 over +2. And that's going to give me a rate of change of -4. And lastly, on the graph, I'm going to do my rise over my run. So I draw my little triangle. I realize my run is 2. And once again, my line is sloping down, so I'm going to have a negative rise. And I realize that it goes down 3. So I take my change in y over my change in x, or my rise over my run, and I get -3 over 2. So -3 over 2 is actually bigger than -5 and -4. So that is going to be my greatest rate of change. So when we're finding the rate of change in these equations, remember it's just the coefficients each time. So here my coefficient is -2, so my rate of change is -2. So I'm going to go ahead and identify all of the coefficients. I'm going to highlight them all in every equation. And then we're going to go through and identify the rate of change. So on number 2, my coefficient is a +4, so my rate of change is 4. On number 3, it's a -9, so my rate of change is -9. On 4, my coefficient is +3, so my rate of change is +3. On 5, my coefficient is -19, so my rate of change is -19. And on 6, my rate of change is +7 because my coefficient was a +7. So just like I said earlier, if you have a y equals mx plus b equation, your rate of change is always the m, which is your coefficient, and also the slope.